Hello everyone. In this video we will learn about a new optimization algorithm, that is Transient Search Optimization Algorithm, that is the Meta-heuristic optimization algorithm inspired by the transient behavior observed in physics systems. This algorithm is introduced in year 2020, and this algorithm is basically inspired by how systems behave during temporary unstable phases before settling into stability. Here, these temporary unstable phases are transient. In simple words, we can say this algorithm mimics how certain systems like electrical circuits go through temporary changes before settling down into a stable state. Done. So here you can see the list of topics that we will cover in this video. First, we will start with what is this algorithm all about, algorithm inspiration, its working, what is transient behavior, and most important, how this algorithm mimics the transient behavior to solve optimization problems. And we will discuss different mathematical models designed in this algorithm. And in the end, we have algorithm application, advantages, and disadvantages. So first question is, what is transient behavior? As this algorithm simulates the transient behavior of electric circuits, so first we will understand this behavior so that we can easily understand how this algorithm is working. So here you can see the main inspiration behind this algorithm, that is the transient behavior of switched electrical circuits that include energy storage elements like inductors and capacitors. And in electric circuits, when you turn a switch on or off, the circuit does not quickly enter its final stage. It oscillates or fluctuates for a temporary period of time before stabilizing. This temporary phase is called transient behavior. Here you can see we have first order circuit and second order circuit. In first order circuit, we have only one energy storage element like capacitor or inductor. And in second order circuit, we have two energy storage elements. You can see here capacitor and inductors. This transient behavior is more complex, often involve oscillation before stability. Here you can see different components for the circuit response. We have transient response and final response, or we can say steady state. Transient response, that is a temporary phase where the circuit oscillates or fluctuates, and final response, that is a stable state circuit reaches after transient die out. For example, if you suddenly turn on light, it may flicker before shining steadily. Here, flickering is the transient response, means that is the temporary phase where the circuit fluctuating. Now, the important question is how this algorithm mimics this transient behavior of circuits to solve optimization problems. So here we will take another example to understand this. Imagine we have a bouncing ball inside a box. At first you can see ball bounces chaotically, that is the transient phase. Here ball is exploring the whole box, and over time the bouncing reduces and the ball settles at the lowest point, that is our steady state. So this algorithm uses this principle to search for the best solution. In this algorithm, transient phase modeled as exploration phase and steady state is modeled as exploitation phase. Now for more understanding, we will try to understand this using this table. Here you can see we compare this algorithm with the transient behavior of electrical circuits. First you can see the model. So first you can see how this algorithm is modeled. This algorithm mimics how the circuits react. It uses this behavior to find out best solution for the problem by exploring, then settling on the best one. Same in electrical circuits, how circuit with inductors and capacitors behave, then switched on or off. So these circuits change over time before settling. So main components in the electric circuit, we have inductors and capacitors. Inductor resists changes in current and capacitor resists changes in voltage. Same in this algorithm, we have search agents, that is our solution. Our search agents will move around and change their position based on these rules to find the best solution. Then means their position evolve based on transient like behavior modeled from the circuit equations. Done. Next we have starting behavior. So in electrical circuits, when a circuit is first powered, it starts with fluctuating behavior and it does not immediately stabilize. So same in this algorithm, first our search agents will explore the search space randomly, jumping around to look for the best answer. This is like the circuit fluctuating behavior. In simple, we can say this is the transient phase, that is temporary fluctuation occur due to the energy changes between inductors and the capacitors. Same in this algorithm, search agents will explore the search space to find out best solution. Next, we have the ending behavior. So in electric circuit, after some time the circuit stop changing and reaches a stable state, that is a steady value. Same in this algorithm, the algorithm will stop jumping around and settle on the best solution. So here we are looking for the problem best solution. So all the search agents will stop and display the best solution. So this is similar to steady state phase. In the steady state phase, system stabilizes after the transient phase and reaching a steady value, that is our final state. Same, the algorithm will focus on exploitation and refining solution to converge to the optimal result, that is the steady state solution. Here you can see this equation. In the electric circuit, you can see second order differential equation. Similarly, in this algorithm, we will use similar equations to update the position of our search agents for the exploration and exploitation phases. Here you can see the circuit behavior can be described using math equation that include the oscillation, or we can say fluctuation, and the steady values. Same in algorithm, we have different equation to update, where the solution means our search agents are just like the circuit changing behavior. Then here we have damping coefficient alpha. In electric circuit, it is used to control how quickly the oscillations decay, means faster damping is equal to quicker stabilization. And in this algorithm, we have to adjust the balance between exploration and exploitation phases by controlling the rate of convergence. Done. How fast it will settle, for this, in this algorithm we will use a parameter capital T. So using this parameter, this algorithm can control how quickly it stop bouncing around and start focusing on finding the best solution, done by using this damping like control parameter T. Same in the electric circuit, how quickly the circuit settle depends on the damping. Next we have exploration and exploitation. So as in the electric circuit, in the beginning the circuit explore different states, means it is oscillating, but eventually it focus on settling to a steady value. Same in this algorithm, will start by exploring widely and randomly, then focus more and get closer to finding the best value. So we will start the exploration. Next we have randomness. So physical properties and the external condition cause variation in the behavior. So as in the electric circuit, physical properties and external condition cause variations in the behavior. Same in this algorithm, we will introduce random number. So using this random number, we will introduce the randomness using, so here we use two coefficients R1 and R2. They are used to simulate dynamic oscillation and maintain diversity in the search space. Done. So this algorithm adds randomness to make sure that it explores different possibilities and does not get stuck too quickly. It means no premature convergence. Same in the electric circuit, the change in the circuit depend on how the elements interact, means how the inductor and the capacitor work together. Next we have control for the balance. As in the electric circuit, the circuit behavior depend on the energy exchange between inductor and the capacitor, which control the rate of change. Same in this algorithm, this behavior is simulated as algorithm will use a special control parameter T to balance between exploration and exploitation. So here you can see this parameter range from -2 to 2, that is used to control the balance between exploration when the value for t is less than 0 and exploitation when t is greater than 0. Done. Same as in the electric circuit, the energy exchange between inductor and the capacitor determines how oscillations and steady state behavior occur. And the final output in the electric circuit, we have final voltage or current reaches a stable state, that is steady state value after transient response fades. Same in this algorithm will converge to the best solution after balancing exploration and exploitation. So the main goal in the electric circuit we have to reach a stable value like voltage or current. Same in this algorithm, goal is to find out the best solution for any problem. Done. So key idea we have in the electric circuit is energy from inductor and the capacitor causes these changes. Same in this algorithm will mimic this behavior to find out the optimal solution, and as in the electrical circuits, it fluctuate before settling. This algorithm will also explore different subspace area, then settles on the best answer. Now, step by step, we will learn how this algorithm is working. First, we will initialize all the important parameters like population size, dimension, or we can say the number of design variables. Maximum number of iterations means how many times the loop will repeat, and after that it will display the best solution. So first, initialize all the important parameters. Step 2, we will generate the initial population using this equation. You can see here lower bound plus random value that is uniformly distributed between 0 and 1. Then we have upper bound minus lower bound. So like in other algorithm, we initialize the population. Same, we will initialize the population randomly in the search space. After this, in step 3, we will apply our fitness function on the initial position and calculate fitness score for each search agent in the current population. Done. In step 4, we will save the best search agent fitness value and location. So as we calculated the fitness score for each search agent, now we will rank the search agents based on their fitness value. If we are doing the minimization, then we will consider the minimum value among all as the best value. And if we are doing the maximization, then consider the maximum value as the best value. Done. Now save the best search agent fitness value and location. Done. In step 5, now the main loop started here. We will repeat this loop until maximum iteration, and when the stopping condition is met, we will display best solution. Now in step 6, we will calculate the value for coefficients, value for t and c1. Here t that we already discussed. So as in this algorithm, the balance between exploration and exploitation phases is managed through a coefficient capital T, and the value for t we have in range -2 to 2 that allow to switch between exploration and exploitation. So using this equation, we will calculate the value for t, and when value for t is less than 0 means algorithm will perform exploration, means algorithm will explore new areas of the search space, and when the value for t is greater than 0, it means algorithm will perform exploitation. Done. Exploitation means algorithm will focus on refining the solution. Done. And using this equation, we can calculate the value for g, that is 2 minus 2. Here t is the current iteration, max t is the maximum iteration, and this value will decrease linearly from 2 to 0. And here you can see we have two random value, R1 and R2. These random values are also used to maintain a balance between exploration and exploitation phases. When R1 value is either greater than or equal to 0.5, it means your exploration, and when R1 is less than 0.5, it means exploitation. Done. So using this equation, we'll calculate the value for T and C1. After this, in step 7, we will check. Here you can see P, that is a random number between 0 and 1. So P is used here to confirm uniform distribution. When the value for P is greater than 0.5, we will update the search agent location using this equation. Here you can see this is the new position x star T, that is the best search agent position in that iteration. After this, you can see we have capital T, that is our random coefficient, and here you can see this is the current position. So when P is greater than 0.5, we will update all search agent position using this equation. When value for P is either less than to 0.5, then we will update using this equation. Here this is the best position, current position, then the value for C1, again we have the best agent. As in the step 7, we calculated the new position values for each search agent. Now in the next step, we will calculate the fitness score for all new agents. So in step 8, calculate the fitness value for the updated search agent's new position. Done. So here we calculated the new fitness score. Now in next step, we will update the best search agent. Done. So here we will compare the previous fitness score with the new one, and accordingly we will update the optimal search agent position and fitness value. Done. After this, we will increment the counter in the current iteration. We will add 1 and then we will repeat the loop. Suppose maximum iteration we have 100. So 100 times this loop will repeat, and after that it will display the best solution. Done. So we can use this algorithm to solve different optimization problem. Because this algorithm results are compared with recent 15 different optimization algorithms, and this algorithm provides efficient results. Here you can see the application. So we can use this algorithm in engineering optimization, in structure design, circuit design, power system optimization, in machine learning for hyperparameter tuning, feature selection, and other, in robotics, image processing, wireless networks, control system like PID controller tuning, and other real-time control optimization. And here you can see the advantages of this algorithm. First, the simplicity of this algorithm. Easy to implement due to its simple mathematical equation. Done. And there is a proper balance between exploration and exploitation phases. So this algorithm use different sine and cosine function to balance between searching, means an exploration, balance between exploration and exploitation. Now we have different disadvantages like premature convergence. Sometimes this algorithm get trapped in the local optima when we have complex landscape. For the high dimensional or high complex problems, this algorithm can face slow convergence. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.